Welcome to Superheroes of Science. I'm Stephen.
And I'm Sarah. We co-host Science from the Experts. Our guests are professionals doing cutting-edge science right now.
They're experts in their field discussing what they know best. So listen up and learn real science from real people.
Subscribe now and stay informed of our latest episodes and show your support. Today on Superheroes of Science, we are so excited to welcome Giovanni Bacon. Giovanni is a graduate student pursuing his PhD in planetary science here at Purdue University. So welcome. Thank you for joining us.
Thank you for having me.
Yes.
All right, but we really want to have you here because we're interested in what you're talking about.
I have a use.
After
that, you're
yeah, that's the only reason we want to do it. But I mean, it's Titan.
Yes.
I mean, you're actually researching Titan, which is, what is Titan? Give us an overview for people that don't know.
What is Titan?
I saw the movie, so I know.
I didn't see the movie. I know.
That was a homework.
Should have done my I should have done my homework. Yeah.
I guess I gotta say a lot more now. Titan is actually amazing, first of all. Titan is one of the largest moons in our entire solar system, the second largest technically, and is Saturn's moon. It's actually Saturn's largest moon, if you want to go for largest. And Titan is one of the only unique planetary bodies similar enough to Earth that is able to maintain an atmosphere. It's able to have rivers, lakes, and even oceans on its surface. No other planetary body does that other than Earth.
But when you say oceans, you mean oceans of water, right?
See, that's the difference actually. That's part of like the bigger difference is that even though it does have these clouds, rivers, lakes, and even oceans, on Earth they're mainly made of water, but on Titan it's mainly of methane. So it has these but methane clouds dropping down liquid methane and creating these methane rivers, lakes, and oceans. And that's what's very crazy is that it's doing this, but not with water.
Oh.
Okay. What kind of temperatures is that then?
Oh, I don't know exact temperatures to be honest, but I can tell you it's very cold. It's actually, because on Earth, methane is mainly in gas form, which means that Earth is too warm for methane to exist as a liquid. But it's so cold on Titan that methane is able to live in this triple state form where it's able to exist as a liquid, as a gas, and as ice.
I remember seeing something, and it might be like misinformation. So you might have to like correct me here. But it would be plausible that there could be like life on Titan.
Yes.
But if it's methane, how is this plausible?
That's the actual fun part. So there's actually two ways there could be life. There could be life as we know it, or life as we don't know it. So life as we know it is how we know life needs to exist on Earth. And so it needs water, it needs, the constituents are part of Earth that make life possible. Mainly it's water. And something with Titan is that near its core, under the surface, it has these liquid water oceans. So a lot of people believe that if it's able to have this liquid water under there, maybe there can be some level of organisms that could live there. Organisms that would be similar enough to Earth, life as we know it, that could live within this liquid water. Or, more interesting to me, is it could be life as we don't know it. It could be these life forms that are different than what we know of Earth. They can be reliant off of something completely separate from what we know of. So we know life on Earth needs water, and we know life on Earth, or life in general, adapts. And so we see that our most abundant resource, water, is something that all life needs on Earth.
Yeah.
But what if on Titan, where they have liquid methane, cloud methanes, and all these just mainly methane constituents, maybe life could have adapted to rely off methane instead of that liquid water. So we want to see how could we find a different form of life? And that's why a lot of people think that there might be life on Titan.
Okay. How would we find out?
Yeah.
We have to send something over there.
Ah, okay.
Yes, and that's actually something that's in the works. They are planning to send a drone to Titan in 2027, and that mission is called the Dragonfly mission. Yeah.
Wow.
Oh, okay. I remember seeing something about the Dragonfly thing, but I wasn't sure what it was doing.
Yeah.
Is it looking just for life, or is it looking for evidence of a life, or is it just like more of a general survey? Do you know?
So it'll be kind of a general survey, but it will have other side missions or secondary objectives. To look at, they're looking at the atmosphere, they're looking at the surface, and they're trying to see like what's how they're affecting each other, what's the make of it. They're trying to get rock samples or surface samples or ice samples for most of it, because most of Titan the surface is ice.
Okay.
But they also want to start looking to see if maybe they can find evidence of life, or maybe they can find life itself over there as well.
Okay.
You said the surface of Titan is ice, like water-based ice, or methane?
Methane.
So the surface with
okay.
methane, but subsurface actually has water.
Okay.
Yes.
Okay.
How do we know that?
How do we know
How
that?
do you know that? You're making this up.
We're guessing. You hope it's right. Well, for one, we've sent a few different probes to kind of look at Titan. Well, mainly to look at Saturn, but they've had secondary missions to look at Titan as it's doing its flybys. And we can take spectra even from some telescopes, space and ground-based telescopes, to kind of see what is the makeup of Titan's surface. And then, once again, looking at this triple state form, we also know it's cold enough for cold enough for methane to exist as ice. And so the surface should have this mainly, or a lot of people say hydrocarbon layer of ice, and that just means like methane, ethane, and other forms.
Oh, okay. Huh. How are you studying this? I mean, you're getting a PhD in this.
Yes.
How are you studying something this far away?
So actually, I'm doing simulations for it. So I'm essentially, what I look at is, my focus is Titan's atmosphere, and seeing how, and watching cloud formations and seeing how they exist on Titan and how they can impact its atmosphere, as well as precipitating, or how rain from these clouds can affect the atmosphere down to its surface. And so I'm creating these simulations of recreating these events and seeing, how do temperatures fluctuate, how could it, what are the necessities for the clouds to form and how they're forming. So mainly this is simulation based or model based, as some people say, but I'm using older data they've taken during the flybys, whether it be with Huygens or Voyagers. They've taken these, or even Hubble, they've taken these images, and I'm trying to recreate the events from the images into the with the simulation, and then that's how I can kind of confirm whether I'm going the right direction with that.
Can you use those then to model what would happen, or then are there do you get into any weather on Titan or anything?
So that's the fun part. Once we can start confirming that we can recreate known events, we can begin, predicting future events and seeing what could we expect, or rather, we can essentially create forecasts for Titan weather.
Wow.
Yeah.
Well, I look forward to seeing that.
Yeah.
Giovanni's weekly forecast of Titan.
We have a few clouds going on. And one of the interesting parts too with the clouds and precipitation, just a little fun fact, is that these rain events on Earth, it probably takes an hour, 2 if you're really unlucky, or lucky, however you enjoy rain. But on Titan, these last for 30 Earth days.
A storm?
A storm lasts for a whole month. Yeah.
Oh, wow.
Whoa.
Talking about the rainy season.
Exactly.
I mean, a month long storms.
Yep.
Now, since you're putting in data for a model, what is the difference between a methane cloud storm and a water cloud storm?
Oh, there's so many differences. Well, the most notable one is the temperature. So temperature is a huge proponent for almost anything that happens anywhere in this universe. And because of that, that can really affect how the clouds are forming, how the methane interacts with each other and the atmosphere in general, and then how long it could take for it to begin raining and how long it takes to rain.
So I'm assuming there's no lightning.
No. Fortunately, or for the model's sake, it's a very stable atmosphere compared to Earth. So Earth has very unstable events which allow lightning to happen. But on Titan, everything's very calm. So it's just it rains.
Well, because I mean, think about it. If it's nothing but methane, and all of a sudden a spark of lightning, then it's like it'd be like the Death Star.
It does seem a little bit like it would be explosive.
Very explosive. Yeah.
It is that taken account when we send probes and things there.
Yes.
Because I mean, you can't really fire an
That's a good
engine
point.
if you're at a planet that's nothing but methane.
Mm-hmm. So yes, that is taken to account. That's why they try to avoid it as much as possible to be where a lot of the storms happen, or a lot of the storms happen, because they mainly happen at the poles of Titan. So towards the equator, it's very, very calm. Well, not many storms or any at all. But even if they did want to go witness storms, that's where my research can come in, and we can tell them, where it's happening, what's happening, the intensities, and what to expect when they start researching, the storm before it happens, during, and after.
Okay.
But even with that, the idea of like being scared of firing up an engine, methane only really becomes volatile when it's around oxygen. So we just have to limit any oxygen in the area, theoretically, and that should allow us to traverse safely. But
Okay.
I'm not really into like how the Dragonfly mission is actually, or how the Dragonfly drone actually works and what it needs to fly.
And I guess I took an assumption when I even asked the question, didn't I, that a methane cloud would act similar to thinking it could be lightning even.
Yeah.
Because maybe it can't. Maybe it doesn't build up static energy like that.
It's possible, with
And
the,
so I didn't even think about that.
But that is a fair question, though, because you're thinking about how it's compared to Earth, and then that's how we look at Titan. Like, what are the differences? What can we compare and what can't we compare when it comes to, weather on Titan or cloud formations on Titan? When it comes to looking at another planetary body with ours in mind.
Gosh, well, I have a question.
Good
So
one.
with the way that water is, we talked about here, water can exist as a gas or a liquid or a solid, and you're saying this can be that way, but all with methane. So water has some really special properties, and one that's coming to mind is like when it freezes, for example, it'll freeze on top, but then below it would still be liquid, so it could still allow, certain life to go. Are there? Is this? How does that affect then if it's just all methane? Are there aspects of that are different now that we're?
That's a really good question, actually, and I think that's one of the things they want to solve with Dragonfly is because as much as we can get, first of all, when it comes to Titan, looking at it with your own eyeballs, you see nothing but this yellow hazy layer. You can't even see the surface. But if we, with recent telescopes, we're able to look at different wavelengths to kind of pierce through it, but it's still difficult to see, and there's still some aspects that we are kind of not assuming, but making educated guesses, but making educated theories about what we're looking at and how they work. But with Dragonfly, we can actually start, getting our boots on the ground and kind of seeing like what is actually there. Are there these frozen lakes happening on Titan, and how could that affect the surface, or how does it affect the potential for life as well?
Right.
Why Titan? Why are we spending time and money to look at this?
A better question. Why not Titan? Titan it's just so cool. Exactly how I mentioned. There are over 150 moons in our solar system, and only one has an atmosphere similar enough to Earth that is able to have these clouds, lakes, rivers, and oceans on its surface. Only one out of 150.
Yeah.
That's why Titan. And Titan can be this, it won't be exactly like Earth, but it could be more of a telltale of what Earth could look like if it didn't have life. Like if it didn't have us affecting it so much, with our carbon footprints and other aspects, how we affect our planet, or how life affects our planet, or intelligent and the very high density of life affects a planet. And we can use Titan as like our gauge. Just how people like to use Mars as what could happen to Earth after it dies, or after it loses water. Instead of looking at essentially our death, we can look at our potential brother.
Progression.
Where we could be.
Oh, well, that's deep.
That is.
I just asked a planet nerd why he studied a planet.
I did not realize that Titan, that there was something that could exist as a solid, liquid, and gas anywhere. I mean, I didn't realize. I was thinking, oh, that's pretty unique. So that's really interesting to learn that Titan has that aspect.
And
it is.
What you're saying, like, that was deep. This conversation was like my whole debate with all my Mars researcher friends. They're like, we should study Mars. It's like, excuse me, you should study Titan, okay?
Yeah.
You should be taking all those rovers and go to Titan. And then when Dragonfly came out, I was like, oh, guess what? Stop talking to us. And it was like, 2027, mark the day.
How long will it take once it leaves Earth to arrive to Titan?
So once again, fortunately and unfortunately, it'll take 7 years to get there. So we won't be able to do any like research until 2034.
Okay.
Oh, wow.
But that's kind of good for me because I don't graduate until 2027 anyway, and that'll allow me to gain experience enough to actually join the mission in a way that I can be impactful.
That's awesome.
So you're planning it out.
Yes. Strategic, no.
Yeah.
But
No, that's smart.
I feel like every time we get in discussions about like planetary science and research and different things, it's just that planning, because everything is like in years, sometimes decades, and that is a lot of.
How long will it take you the data back then?
Yeah.
Oh man, it's.
I mean, how are they sending data back? I don't even know how they do it on the rover. Have we asked anybody that?
I don't think so.
They relay it through like essentially antennas. How it works how a phone relates information to a satellite.
Yeah.
It's just for here it's a lot more instant because of the distance, but I believe it might take like a day
Okay.
before they can like.
Well, it's waves at the speed of light, right?
Yeah.
So, okay. Yeah, that makes sense.
But they want to make sure like everything's working. They want to make sure everything gets a command at the same time.
Yeah.
So I believe they said they wanted to like wait a day before they can confirm whether all the information was sent and nothing was like blocked out.
I see.
So they don't mess up this $1 billion project on another planet.
That makes sense.
Yeah.
That makes sense. But I don't know. I've heard of like the planetary. Well, I want to say planetary defense, but I think that's the one NASA's like defending Earth. But isn't there a planetary defense where you have to protect planetoids that we're visiting? There's protocols.
That's a very interesting and important question. And I believe there's people working on that. It's very difficult because a lot of us are scientists. And now what you're talking about is science protection, but with politics. And the politics aspect is what makes it very, very difficult. So,
but more than politics, it's ethics at that point, right?
Politics, ethics, it's so much. Because sometimes it's want to say like, blow it up, see what we get. Sometimes it's like, don't touch it, just witness it as it is.
Right.
Yeah.
And other people are, other versions of entrepreneurs are like, how can we monetize? How can we monetize this? And it's just like all these things are competing against each other because we need money to send projects, but we need to not affect it to learn about it. But sometimes we need to really affect it to see what we can learn about it. It's just this pull and tug from every direction. It's very difficult to find the balance of.
Where do you see your future role in all this?
My future?
Yeah. Because you have a master's, right?
Yeah, actually, I just went from my undergrad straight to PhD.
Oh, you jumped in
nice.
straight.
Okay. Yeah.
All right, well, you have a degree in
astronomy and astrophysics.
Okay, astronomy and astrophysics. So we have an astrophysicist here. But okay, so you have a degree right now in astronomy and astrophysics. You're working on a degree that will be what?
Planetary science, looking at planetary atmosphere.
Okay, so you'll be a doctorate in planetary science.
Yes.
So what do you see when we start getting data back from the Dragonfly? What, ideally, is your role? Where do you see yourself there?
I see myself in confirming my PhD project and seeing like where my projections correct, were certain assumptions that I made correct, or comparing to other papers where they've done similar things, and then seeing how I can make models stronger. And the funnest part is seeing what's really out there, like getting real-time data and seeing like, well, okay, I was wrong, that sucks, but this is why I was wrong. That's amazing.
Yeah,
that's an amazing thing to learn.
My gosh.
And that's what I look forward to.
Well, good. Thank you for your time.
Absolutely.
Well, thank you for having me.
Thank you for listening to this episode of Science from the Experts from Purdue University Superheroes of Science.
If you like this episode, subscribe, give us a positive review, and share the love. Boiler up!
Hammer down.